Hi, hello. So today I wanted to show you a deployment about gateway high availability. So I have a simple hand-drawn diagram here. Let's see. Let's assume client is your laptop or workstation at home, and then you have two internet gateway for internet access. So this is like a high availability scenario. For example, if for some reason your gateway router one goes down, and then the gateway router two will take the gateway role and route the traffic for the client. So here, see, I use the software. So this is the software I use. They are very pretty stable. So Firehol is for the gateway routing, which use the IP tables underneath. So this is a Firehol is a very stable project for gateway or router for internet access. And so for the high availability, I use the keepalived, which is another open source software, very stable. And yeah, so I'll use these two open source software for high availability gateway. Yeah, so I'm going to demo the configuration and see to check the function of high availability. So gateway one, gateway two, the client, and let's assume the server is the internet, is the server on the internet. Okay. So here is my gateway. Gateway one, router one. So here is the gateway 1, 2, router 2. So I also run this gateway in a different version. So this gateway is Ubuntu 16.04. Okay, so this gateway is Ubuntu 20.04. Because the Firehol gateway software use the IP tables underneath, but since 22.04, the Ubuntu will use the NF tables. So the IP tables is deprecated, and it becomes a legacy legacy software for firewall. So 2004 is the last one to support the IP tables, legacy IP tables for firewall. And so I run this 2004. So 16.04, of course, still support the IP tables. Okay, so here is my configuration. Let me show you the Firehol configuration for the high availability. Okay, so just needed to be aware because by default, once you have Firehol running, by default, the HA high availability protocol message VRRP is rejected by the Firehol IP table firewall rules. So you needed to custom define these VRRP ports. Actually, VRRP is like a icmp protocol, it has no ports. So you can say it listens on any port. So we define the server VRRP ports here with protocol and port any, and the client port is any. So this is I borrowed from the icmp definition in the Firehol. So you need to have this. So the VRRP message can be exchanged between the two gateways. Okay, so here is my home interface, and since I have the VRRP high availability message transmitted over this home interface for home network, so both server and the client, I allow the VRRP protocol. Okay, so this is important. You gotta make sure that the VRRP can be transmitted between the two gateways. Otherwise, you will have like a two gateway act as a master to route the traffic, which will cause conflict. Okay, so this is the thing you needed to be aware for Firehol to allow the high availability VRRP message to be allowed. Okay, so that's for the Firehol. Now let's look at the keepalived. It is the keepalived. So I have every option. So I have a very simple keepalived deconfiguration. So just a few atoms, and so here the state master is that if you want this router to be the master when it is healthy, and always be master, and you can set the state preference as master. So this actually is depend on the priority number we defined below here. So this is a priority number. So you will have a higher priority number than the backup gateway firewall. So here we have a 101. Okay, so the interface is define the interface where the VRRP message is it's exchanged between the gateways. So the two gateway will talk with each other with VRRP to decide which one should be master. So this is the interface. And so the router ID is, it's just they share the same router ID, two gateways. Not much talk about. So, and here we use VMAC. So, and to use like a virtual MAC address, but for some reason the virtual MAC address is not used here in my deployment, and that's fine because it doesn't affect the function. So this one actually is important VMAC transmit base, which means for the GARP message. So when you're when your gateway when your gateway server say 1 is down, and then when this gateway becomes master and becomes master, it will send a gratitude ARP message to the whole network, the home network, telling every switches, workstations, PCs, that the virtual gateway IP address 10.172.118 is using a MAC address of this interface. Okay, so that's the VMAC transmit base means using the underlying interface MAC address. So in this scenario, it uses since this is a gateway virtual IP, and it is on interface ES 1101. So when GARP is transmitted, will with the source MAC address of this interface. So scenario, it will be this one. Okay. And yeah, so this advert interval is the VRRP message time interval. By default is 1 second. You can define a 5 second, and yeah. And priority 101 again is a higher priority number, is a higher priority. So it will become a master once it's when it's healthy. So the unicast, so in some network environment, the multicast is not supported. So we use unicast here. So the unicast source IP for the VRRP message is the IP for this interface. So this IP is on this interface. That's the IP. So the peer is the peer gateway IP address for VRRP exchange. Again, the virtual IP address. So this is the actual gateway virtual IP will be used in high availability. And so yeah, for example, right now, this Ubuntu 16.04 is the master gateway. I can show you the IP address here. So on this home interface, I have so this is the gateway virtual IP. You can see now here it's on this home interface. So the home network will go through gateway of this IP address. Okay. Yeah, for example, so this is my home workstation. Say IPA show, and I have this home network 10.1 72. Okay. So then I have my gateway is like say I wanted to ping a server in this network, and then so I use this virtual gateway IP because again in my lab it's not a real home network environment. I have a lot of multiple network on this workstation. So I just so I'm just assuming this is internet network, and then if my client wanted to go to this network, it will use this virtual gateway IP. Okay, 118, and here this is 118 virtual gateway, right? Here virtual gateway IP here. Okay, so right now it's you can see if I ping a server, on this 10.169.72.x network, assuming this is the internet, and if I ping a server 114 IP, and it should working, right? It should go through the virtual gateway IP. Okay, so it's working right now. So so this is my master gateway, and this is the backup gateway. this is a backup gateway. You can see here on this home interface, there is no virtual gateway IP on this interface because right now it is the backup gateway, right? So the virtual gateway IP is here 118. Now, what if we right now I wanted to simulate failover. Say, let me set this link down. IP link set this interface. So this gateway home interface. Let's set it down. And let's see, we will see if our pin still work or not, right? So now the link is down. And let's show the IP address again. You can see here, this home gateway interface is down. And as you can see now, the virtual gateway IP disappeared, right? So this master gateway server is down, link is down, and the virtual IP disappeared immediately, and our pin still works. So we should assume that the virtual gateway IP should be on the backup backup gateway. Let's just double check here. So right now we don't have the 118, we only have 117, right? No virtual gateway IP previously shown. So let's show again here. And now you can see here, we have the virtual gateway IP assigned automatically on this backup gateway. So now this backup gateway becomes the master, and there's no traffic interruption. As you can see below here, the icmp is working. And yeah, so okay. So right now, if we wanted to set put the link backup on the original master backup, original master gateway, let's set the link down, set the link up, and let's show the IP address again. So on this home interface, the virtual gateway IP is on this master gateway again, and it's not in the backup, so it's gone. There's no 118, and so 118 back to this master gateway, and the pin keeps working, right? Now let's double check the GARP. Maybe we should see the IESE01 ARP and host. So let's just simulate the failover again and see what's the gratitude ARP message look like. Okay, so here I will, on this backup gateway, I will run TCP down on the home interface to capture the ARP message with a host as the virtual gateway IP. Okay, so right now we don't have any GARP gratitude ARP message because no failover event. But if I wanted to set the link down on this master gateway, we should see here. Now we write it. We get it immediately. We get the GARP message, and yeah, actually I should do it because I should set it backup. because I want to show the MAC address. Okay, show the MAC address. Let's give a -e. So -e will show the MAC address of this message. And let's do the filter again. Set it down. And we see the GARP with the broadcast. So the GARP message, GARP is like a broadcast to the whole network with the source MAC address of say 07FA. So it means like this virtual gateway IP, there's a failover happened, and this virtual gateway IP 10.172.118 is on this MAC address. So when all the switches or the home workstations receive this broadcast message, it will say, oh, this virtual gateway IP is on this MAC address. So the workstation switch will refresh their port, their ARP, and to route the traffic to when they want to route traffic through the gateway, they will use this as the gateway's MAC address. Okay, that's the GARP look like. So you can see below the ping always working, even I have done a few failover test. So again, this is on the backup. Right now, let's see. So yeah, the virtual server, the virtual gateway. So we can show the keepalived, and we will see the logs here in the master. So it says entering fault state. Can't send the VRRP message to the peer because I set the link down, and it's in a fault state. Okay, and here let's see the backup. Keepalived, it should be assessed become a master. So this is from enter backup state. The last one is entering master state, right? Okay, so we can look at the backup. We didn't look at the backup router here. The keepalived. So again here, the preferred state is backup, and the priority number is on 100, which is smaller than the master priority number. And then, so everything else is pretty much the same. The virtual IP, gateway IP here, 118 on this interface, on this home interface. Okay. Yeah. So this is a scenario you want when you want to have a high availability for your gateway, and even you run a different version, Ubuntu 16.04 and or 20.04. The keepalived version is different. The Firehol version is different, but they can still work together as a HA pair. And yeah, so thanks for watching.